Hello everyone, welcome back to my channel. This is Richard Chama, and today we'll be doing a topic in biology, which is diffusion. We'll be doing diffusion. Now, we'll first start by defining what diffusion is. So, diffusion is simply the movement of particles from a region of higher concentration to a region of lower concentration. Now, through a concentration gradient. That's the whole definition of diffusion. So what concentration gradient is that it's simply the concentration of particles in an area. That's a concentration gradient. Now I'm going to draw some diagrams to explain what concentration gradient is and how concentration gradient is connected with diffusion. So now let's look at this. Let's say this is a beaker, right? Then it contains water, right, with water particles, which are these water particles. Then it has these other particles, very small particles, which we could say a sugar, they say, right? So this solution, it's a sugar solution, has a concentration gradient where there are particles that are more concentrated and there are particles that are less concentrated. Okay, then you find that at times there are these particles move from this area, they say, to a different area, right? Now let me just show another diagram that shows diffusion. So let's say this is another beaker, right? There is still water particles in there, right? And then someone adds sugar, right? Let's say this is someone sorry, a diagram. Someone adds sugar, right? Add sugar to this. Yeah, so when the sugar is placed in this solution, let's say this is the sugar right here. So the sugar particles starts to move. Okay, they start to diffuse from this region where they're concentrated to a region where there is no sugar. Okay, and this sugar won't stop until the concentration in the whole solution is the same. Okay, so that's the introduction to diffusion. From there, we can also say that diffusion takes place in solid, liquid, and gas. Okay, so these are also the three states of matter. So this is where diffusion takes place. Okay, now we're going to give some experiments or some examples that show the diffusion of substances in liquid and gas. Then in solid, we'll do it at the end of the video. This is rarely talked about, so it will be like a bonus point. If you make it at the end of the video, you'll see how diffusion takes place in solids. But otherwise, for now, we're going to talk about liquids and gases. So we'll start with gases. Okay, gases. So one of the experiments that has been used to describe the movement of particles, of air particles rather, into the environment is by using a bottle of ethanol. Okay, ethanol. So many of the times the bottle should contain at least 98% of ethanol. Then what this bottle of ethanol is done with is that it's left open in a certain room, right? Or even the room you're watching this video from right now. You just get a bottle of ethanol, then you leave it open for like 5 to 10 minutes. Then what you observe is that the room smell or scent will change. Why? Because the particles in ethanol, let me even draw a bottle here. Sorry, my bottle is not the best. Yeah, sorry, my bad. So let's say this is a bottle of ethanol. Let's say it was full. Then this is the lid or something. Yeah, so the particles of ethanol, right, diffuse to the environment, right? They move from the bottle to the environment where there is less concentration of ethanol. Now, logically speaking, the room you're in right now, I believe that there is no alcohol, there is no scent of ethanol unless you're drinking right now. But many of the times there is no ethanol, right? Then when you open the bottle, the particles in ethanol will start diffusing. They will move from the bottle to the environment, causing or bringing about diffusion. Okay, then the other experiments pertaining or concerning gas is, where you can cut an onion. You can cut an onion or a lemon or an orange. Then you are able to detect the change in the smell of the environment. We all know that onion, it has a certain scent once it's cut. Sometimes it can even irritate your eyes. I think if girls are watching this video, you can bear with me. When you're cooking, then you're chopping your onions, yeah, many of the times they cry and whatnot due to the diffusion of the gas produced from lemon into their eyes. Okay, then we'll discuss on how we can solve that problem, how you can reduce the crying when you start looking at the factors of diffusion. So that's about gas. Then going to liquid, right? Liquid, I'm going to write it here. Liquid. Okay, so now liquid, you can just get a beaker. This is another experiment, by the way. You can get a beaker and water and potassium permanganate. Okay, if you don't have potassium permanganate, you can just get any color, right? Any color, or you can get a leaf, pound it, then the chlorophyll, you can use that. Okay, then once you dip that potassium permanganate or any color that you might have in your house, or a leaf that is crushed, you will notice that when you place that in water, the color will move from where the leaf or the source is to other particles or to the surrounding area. In this case, we'll say water. So that is diffusion, because the color of that particular particle in the water is moving, okay, bringing about diffusion. Okay, then from there we go to the factors that affect the rate of diffusion. Okay, now we will talk about 4 factors. 1, 2, 3, 4. There are 4 factors that we'll talk about. The first one being temperature. Okay, temperature. Yeah. Now, how does temperature act as a factor of diffusion? So you find that when temperature is high in a certain area, or particularly where that solution or that substance you're dealing with is, temperature increases the kinetic energy of that particular substance. Okay, kinetic energy. Sorry, I won't finish that. So it increases the kinetic energy. Now, let's say you are doing the same solution, the same experiment, where potassium permanganate and water, right? So when you heat up the solution, the rate of reaction will increase because the particles in water are gaining more kinetic energy, right? Which kinetic energy is simply the energy that enables particles to move. So when the kinetic energy has increased, the particles will be moving very fast, such that the concentration gradient will mix up very fast, or the collision will happen very fast. So that's how temperature affects diffusion. Then the second factor that affects diffusion is the concentration gradient. Okay, concentration gradient. Okay, yeah. So now, how does concentration gradient affect diffusion? Okay, so what happens is that when the concentration gradient is high, and going by the definition of concentration gradient is the difference in particles, or the difference in concentration of particles, then the collision or the movement of those particles will be very high. Now imagine this, let's say water. Again, this is water. Then the salt that has been added is a lot, right? The quantity is very high, meaning these particles will move more. They will move in numbers. They will move faster because they are a lot. That's a concentration gradient compared to the water. We all know that when you add a very high amount of salt, or sugar rather, in tea, you don't have to stir for a very long time for it to be sweet or bitter. Okay, so that's how the concentration gradient affects the rate of diffusion. Then the second factor that affects the rate of diffusion is a semi-permeable membrane, or the thickness of a semi-permeable membrane. So I'll just write thickness of a membrane. Okay, membrane. So this one is basically associated with osmosis, right? Which is a movement of particles from a movement of water molecules. That's osmosis. Keep this definition in mind. So osmosis is the movement of water molecules from a region of higher concentration to a region of lower concentration through a semi-permeable membrane. Okay, so this factor right here basically, or many of the times, affects osmosis and not diffusion because it deals with a semi-permeable membrane. So if the membrane is thick, right, it takes time for the particles to move from one region to another, hence reducing the diffusion rate. Okay, so that's how thickness of a membrane can affect diffusion. Then the last but not the least factor that affects the rate of diffusion is the size of the particles. Okay, size of the particles, right? Now, so if you have very huge sized particles in a solution, for example, let's say this is a sugar molecule, right? Then for it to move to this area, it will be very hard because it's heavy, and it takes time for bigger objects to move. Same applies to athletes. I've never seen an athletic person who is chubby or fat. Don't get offensive if the person watching this, you're chubby. I'm also chubby, right? But I've never seen an athletic person who is chubby, right? Because they have trouble moving. But very few athletic people are fat. Many of them are slim and all that. So that also adds on to the factor that affects diffusion. Okay, I think, yeah. Okay, then from there we're going to talk about osmosis in living organisms, to be specific, in animals and plants. Okay, so there are times where these water molecules move from living cells rather. Then this is brought about due to the immersion or the usage of certain solutions which are called hypertonic, hypertonic, hypertonic. Then there is hypotonic solution. Then there is isotonic solution. Okay, now when a living cell, by the way, is placed in a hypertonic solution, what happens to this cell is that, one, it loses its water, right? It loses its water to that particular solution. Then if this process continues, right, the cell could shrink, and once it shrinks, that is known to be as cell crenation. So I'll draw a diagram to show how this happens. So let's say this is a beaker containing the hypertonic. Then this is a cell, right? So if a cell is placed in this solution, it starts to lose water, right? It loses water to the solution. Then it shrinks. It becomes something like this. I'll draw down here. It becomes, if it's round, it becomes like this. Okay, it shrinks, right? Then when this happens, this condition in biology, it's known as cell crenation. So right, crenation right here. Then when a cell is placed into a hypotonic solution, I'll write it here, hypotonic solution, what happens is that this cell right here, this cell will gain or absorb water from the solution. Then it absorbing water, it will swell up, right? And if this condition continues, it may burst, simply because an animal cell only has a cell wall. It has a cell membrane and no cell wall, meaning it's not protected by the cell wall, so it may burst. Then this condition now will be referred to as cell lysis. When the cell bursts, okay, that's cell lysis. Then I have an isotonic solution is simply a solution where the concentration in the cell is the same as the concentration in the solution. So that's the isotonic solution. Now, relating or comparing with a plant cell. Okay, a plant cell. Okay, so a plant cell when placed into the same solution, a plant cell when placed into the same solution, which is hypertonic, a plant cell is a plant cell, it also loses water, right? It also loses water. And in a plant cell, this condition is known as cell diplasmolysis. Diplasmolysis. Sorry. Yeah, okay, actually, it is cell diplasmolysis. Sorry, my bad. Yeah, this is in a plant cell. Then, when it's placed into a hypotonic, which is less concentrated, a hypotonic solution, a plant cell again, it absorbs water. Okay, it absorbs water, then it becomes turgid. But with a plant cell, it does not burst. Why? Because it has a cell wall. It has a cell wall which is tough, right? And it resists more entry of water when it has absorbed enough water already. So this one does not burst and this one bursts. Okay, yeah, so I think this will be the end of our tutorial, although there is the bonus, yeah, where diffusion in solids. So diffusion in solids is not a very big thing. Actually, you just you know combine solids. For example, let's say chalk powder and rice. Okay, this is chalk and rice. Okay, so when you combine this into a beaker and shake it, okay, that's diffusion in solids. Okay, so yeah, it's not that interesting, but that's diffusion in solids. So thank you for watching. Don't forget to like and subscribe to the channel, and if there is any topic you'd like me to do, please comment in the comment section and I'll be sure to get to you. Thank you very much. See you next time.